Hey guys, welcome back to my channel. So for those who don't know me, I'm almost engineer Emanuel Vallejera, and I'm currently on my last year taking up BS Chemical Engineering in UP Diliman. So today we're gonna do a new challenge that was requested by some of you, a 5-minute Q&A with me. So what I'll do is I'll get 4 questions from everyone who used the hashtag AskAlmostEngineer on Twitter. So the first question is from Paulito Cruz, who asked, give a time when you had to use your engineering knowledge or skills to solve a real life problem. Alright, so for us Eng students, 3-in-1 coffee is life. And if you have coffee that won't mix because the water is too cold, or if you have scalding hot coffee that you can't drink, then you could just use everyday cheming concepts to get that perfect cup of coffee. Especially with heat and mass transfer concepts. And trust me, those things would really happen during Hell Weeks in UP. When you forget to use hot water for 3-in-1 mixes, a good tip is to mix it not in one direction, but in random directions, because this would dissolve the powder faster since you're increasing the turbulence of your system, which would allow more water molecules to interact and essentially dissolve the coffee powder. And if you have a really hot cup of coffee, you could easily cool it down by putting it in an ice bath. So it's easier for heat to escape from the cup to the ice bath compared to air, since water would have a higher heat capacity. And the larger temperature difference of the cup and ice bath compared to with air makes heat escape faster to the ice bath. So the next time your coffee gets too hot, put it in an ice bath to cool it faster. And so I hope those 2 answers would give you an idea when you need your coffee fast, hot, and well mixed. Thank you for your question, Paolo. Okay, so going now to our next question from Amira Mendez, who asked, how would you use your engineering practice to champion for one of Unilever's sustainable living program to reduce environmental impact I have? So thank you for that wonderful question about sustainability, Amira. And as a chemical engineer, the 3 main points that resonated me from the USLP are 1. Waste reduction from packaging, 2. Reduction of emissions by using cleaner fuel sources, and 3 is the ethical and sustainable sourcing of raw materials. And I think that the main driving force for achieving this goal is to have a cohesive and active cooperation among manufacturing companies to agree on 1. The use of paper instead of plastic packaging, 2. To enable, support, and patronize renewable energy sources in the market to decarbonize both the manufacturing and energy industry at the same time. So this would allow us to continually reduce our greenhouse gas emissions. And also patronizing the use of electric transportation via freight also ties in very well to this point. And lastly is to pursue an industry-wide agreement on developing regional and rural agro-dealer networks by ensuring that at least 25% of ingredients used are locally and ethically sourced to increase the livelihood of small farmers worldwide. And I think that achieving these goals would greatly contribute to the reduction of the company's environmental impact. And again, thank you Amira for that question. You made my chem and heart very jubilant. Okay, so we're now down to our last 2 questions, and this question is from Aisha Reyes, and she asks, just for fun, how many tennis balls can you fit in a regular taxi? Say a Toyota Vios, for example. So let's look at this with the chemical engineering perspective. Let's lay out our solution. So to get the number of ping pong balls that can fit inside the car, I need to get first the volume of the car, and then I need to get the volume of 1 ping pong ball, and I'll divide the volume of the car with the volume of a ping pong ball. And that gives us the number of ping pong balls that can fit inside the car. And with any of the chemical engineering problems, you have to start first with your assumptions. So let's assume that the shape of a car is a rectangular prism, and when I sleep inside the car, my whole body fits in the front seat. And let's say that's around 1.5 of me, and I'm 5'10", so that means the length of the car is around 270 centimeters. And the width of the car is around my size, so that would be 150 centimeters. And lastly, the height would be 2/3 of my height, which is 120 centimeters. Now let's say that a ping pong ball would be around 7.5 centimeters. And let's put a factor of safety since we would usually use it whenever we're designing distillation columns or reactors. So maybe you can over-design the prism by 50% or by multiplying the volume by 1.3. So you can think of it as the volume needed for the extra spaces in the car. Like for example, maybe we could also put the balls inside the trunk, or maybe put it inside the stuffing of the couches, or put it inside the tires. So that would account for the extra spaces. So now let's compute. The volume would be computed using the formula length times width times height for a prism, which would mean it would give us a volume of around 6 million cubic centimeters. And we need to still multiply that by 1.3, which makes it around 7.6. And now for the volume of one ping pong ball, so the formula is 4/3 pi cubed, and the radius of the ball is half of the diameter, which is 3.75 centimeters. And plugging that in, you get a volume of around 220 cubic centimeters. So the number of balls is equal to the volume of the car divided by that of the ping pong balls, which gives us around 34,462 balls. That's a lot of balls. So if you're crazy enough to do it, then why not, Isha? Thank you for that headache-inducing question. I hope you get those balls from very, very cheap suppliers. Choose. Okay, so now we're down to our last question, and this last question comes from Alfonso, who asks, if ads were removed from Facebook, how would you monetize it? So I think there are a lot of ways for us to monetize on Facebook, even if ads were removed. So Facebook is really keen on developing its core values of connecting people. So there's so much more untapped potential for connecting with people that we need to explore on. And if we bank on the idea of creating easier connections with people, we can introduce unlockable features on Facebook such as group video conferencing. And we can also enhance their user experience by making Facebook personalizable for them by introducing Facebook layouts which anyone can customize for their needs. So thank you guys